April 17th, 1943. Benghazi Airfield, Libya. The metallic clang of a wrench hitting concrete echoed across the dusty hangar as Charlie Hammonds slammed his tool down in frustration. Sweat dripped from his forehead, leaving streaks in the grime that coated his face after 14 hours of work on the captured Messerschmitt Bf 109F. The temperature inside the makeshift hangar had reached 104 degrees, turning the space into an oven that smelled of aviation fuel, oil, and the distinctive acrid odor of burned German hydraulic fluid. 2 goddamn days, he muttered, wiping his brow with a rag that was already black with grease. 2 days and I'm still getting nowhere. Behind him, the sleek profile of the Messerschmitt sat partially dismantled, its cowling removed to expose the Daimler-Benz DB 601E engine. The aircraft had been captured relatively intact after a forced landing 30 miles south of their position, its pilot having misjudged his fuel consumption during a reconnaissance mission. The plane represented a prize beyond measure for the desperate Allied forces struggling to maintain air superiority with dwindling aircraft supplies. "Hammond!" The voice cut through the hangar like a knife. Major Robert Ellsworth strode toward him, his khaki uniform still somehow crisp despite the oppressive heat. "Tell me you've got good news." Charlie straightened up, wiping his hands on his coveralls. At 34, he was older than most of the mechanics in the 10th Air Recovery and Repair Unit. His thinning brown hair and perpetual squint from years in Detroit auto factories made him look even older. "No, sir. Not yet," Charlie replied. "This Daimler engine uses a completely different fuel injection system than anything we've got. I've tried adapting our fuel lines, but the pressures are all wrong. She'll start, but she'll flame out the minute you try to give her throttle." Ellsworth's face tightened. "Hammond, I don't need to tell you what we're up against. Intelligence reports 3 German convoys moving toward Kasserine. Our P-40s are down to 30% operational capacity. General Stevens is demanding every serviceable aircraft within 24 hours. I understand that, sir, but no buts, Hammond. The 27th needs those planes. We've got 16 pilots and only 9 operational aircraft. That's why I brought you here from England. Your reputation preceded you." Charlie looked at the Messerschmitt. It wasn't the only one. Through the open hangar doors, he could see 5 more captured German aircraft in various states of disrepair. 3 more Bf 109s, a Focke-Wulf 190, and a Junkers Ju 88 bomber. All potentially flyable. All grounded by incompatible systems, parts that didn't exist in Allied supply chains, and maintenance manuals written in German. "Sir, with respect, what you're asking is—" Charlie hesitated. "Impossible?" Ellsworth raised an eyebrow. "That's not what I heard about Detroit's miracle worker. The man who kept a 37 Packard running with Chevrolet parts during the Midwest parts shortage." Charlie ran his hand along the Messerschmitt's fuselage. The aircraft was a masterpiece of German engineering, precise, efficient, and utterly incompatible with American or British components. Conventional wisdom held that captured enemy aircraft were useful only for intelligence or spare parts. No one had successfully integrated enemy aircraft into Allied squadrons for combat operations. The differences were too fundamental. "Give me the night," Charlie said suddenly, his eyes fixed on the engine. Something had clicked in his mind. Not a solution yet, but the possibility of one. "There might be a way." Ellsworth checked his watch. "You have until 600 tomorrow. After that, these planes get cannibalized for parts." After the major left, Charlie stood alone with the German fighter. Outside, the sun was setting over the North African desert, casting long shadows across the airfield. In the distance, he could hear the distinctive rumble of American P-40 Warhawks returning from patrol, their Allison engines producing a different pitch than the liquid-cooled German Daimlers. Charlie crawled back under the Messerschmitt's engine cowling, his mind racing. The problem wasn't just technical, it was philosophical. Everyone was trying to make German planes work with American parts. What if the approach was backward? At 2200 hours, Technical Sergeant Wilson appeared with a thermos of coffee. "Still at it, Charlie. Everyone else packed it in hours ago." Charlie emerged from beneath the aircraft, his face streaked with oil, but his eyes bright with excitement. "I think I've got it, Will. We've been trying to Americanize these German planes. What if instead we Germanize our support equipment?" Wilson looked skeptical. "What are you talking about? These planes don't need American fuel systems. They need their own systems fed with our fuel. The mixture's different, but the chemistry isn't incompatible. We need to build an adapter, a bridge between our world and theirs." Charlie grabbed a piece of paper and began sketching rapidly. "If I can create a conversion manifold here and rework the fuel pressure regulator, we could keep the German injection system intact while feeding it properly regulated American fuel." Wilson stared at the rough drawing. "That's crazy, Hammond. You'd need to fabricate custom parts we don't have specs for." "Exactly," Charlie grinned. "It's so crazy it just might work." As the North African night grew cold, Charlie Hammonds hunched over his workbench, the single light bulb casting harsh shadows as he began grinding a piece of salvaged aluminum into something that had never existed before. A bridge between enemies, a translation device for machines of war. By morning, either he would make history or prove that some divides couldn't be crossed. The fate of the coming battle might hang in the balance. March 10th, 1941. Willow Run Factory, Ypsilanti, Michigan. The thunderous clamour of pneumatic tools filled the cavernous assembly building as Charlie Hammonds manoeuvred around the partially assembled wing of a B-24 Liberator. At 32, he looked older than his years, with calloused hands that told the story of a lifetime spent coaxing machinery into cooperation. His face, angular with high cheekbones and deep-set eyes, carried the permanent squint of a man who had spent too many hours peering at mechanical tolerances measured in thousandths of an inch. "Hammond, you're wanted in the foreman's office," called out a passing floor manager, barely audible above the industrial cacophony. The foreman's office was a glass-walled island in the sea of manufacturing chaos. Inside, Charlie found not only his supervisor, but two men in Army Air Corps uniforms. "This is Lieutenant Colonel Davis and Captain Miller," the foreman said without preamble. "They've been asking about that fuel pump modification you developed last month." Charlie nodded cautiously. The modification had been his own initiative, an improvised solution when supply chain issues had threatened to halt production. By adapting truck fuel pumps to work in aircraft engines, he had kept the assembly line moving. "Mr. Hammonds," Colonel Davis began, "your reputation is interesting. 20 years in automotive work, specializing in cross-platform adaptations. No formal engineering degree, yet Ford, Packard, and now Consolidated Aircraft all cite your work as breakthrough." Charlie shifted uncomfortably. "Just practical solutions to practical problems, sir." "That's precisely what we need," Davis replied, sliding a folder across the desk. "The Army Air Corps is forming specialized recovery units. The war in Europe is generating an unexpected resource, damaged and abandoned enemy aircraft. Currently, we can only use them for parts or study. We need someone who can think beyond the manual." 2 weeks later, Charlie found himself at Chanute Field, Illinois, teaching a hastily assembled team of mechanics how to identify compatibility between seemingly disparate systems. The men came from diverse backgrounds: former race car mechanics, farm equipment repairmen, and aviation technicians, all selected for their improvisational abilities rather than formal training. "The Germans and Italians approach mechanical design differently than we do," Charlie explained to the group gathered around an engine display. "They're not better or worse, just different. Think of it like languages. They're all saying the same thing, make this piston go up and down, but the grammar is different." Private First Class Samuel Williams, a former dirt track mechanic from Georgia, raised his hand. "But sir, we don't have parts catalogs, specs, or anything for these Kraut planes." "That's why we're here, Williams. We're going to create the dictionary that translates between these mechanical languages." The training was intense and unorthodox. Charlie had the men disassemble and reassemble engines blindfolded to develop tactile familiarity with components. They studied captured German maintenance manuals, working with linguists to decipher technical terminology, they fabricated tools to match the metric specifications used in European designs. Most importantly, Charlie instilled in them his fundamental philosophy. Everything can be fixed. Nothing is incompatible if you understand the principles behind why it was built that way. By December 1941, as Pearl Harbor thrust America fully into the war, Charlie's experimental unit had successfully modified 3 captured Italian Fiat G50 fighters from the North African theater to run on American fuels and accept some American parts. But these conversions had been performed stateside, with full workshop facilities and unlimited time, luxuries that would not exist in combat zones. The true test came in August 1942, when Charlie and a select team of 12 specialists were deployed to RAF Heliopolis in Egypt. The British, stretched thin across multiple fronts, had accumulated dozens of captured German and Italian aircraft, but lacked the resources to utilize them effectively. Upon arrival, Charlie surveyed the aircraft boneyard with a mechanic's calculating eye. Messerschmitts, Makis, and Fiats baked in the desert sun, their camouflage paint schemes fading in the harsh light. To most, they represented intelligence windfalls or parts donors. To Charlie, they were a fleet waiting to be awakened. "Our fuel has different octane ratings than theirs," he explained to the skeptical British engineering officer. "Their hydraulic systems use different pressures. Their electronics run on different voltages, but the laws of physics are universal." The British officer, Wing Commander Ashton, remained dubious. "We've tried, Hammond. The tolerances are all wrong. Our ammunition doesn't fit their guns. Our radio equipment doesn't match their frequency ranges." Charlie walked up to a relatively intact Macchi C-202 fighter and ran his hand along its aluminum skin. "This is a 1,175 horsepower machine capable of 372 miles per hour. Sitting here, it's just metal. Give me 3 weeks with this one." Working 18-hour days in the punishing Egyptian heat, Charlie and his team tackled the Macchi first, creating what they called translation components, adapters that allowed American parts to communicate with Italian systems. The breakthrough came when Charlie realized they needed to stop thinking of the modifications as permanent. "We're not rebuilding these as American planes," he told his exhausted team one night. "We're creating a temporary bridge, a handshake between technologies." After 20 days of relentless work, Charlie invited Wing Commander Ashton to witness the test. The Macchi's engine roared to life, its distinctive sound unchanged, despite now running on American aviation fuel through a hybrid fuel delivery system. 2 days later, a British pilot flew the converted Macchi on a successful test flight. Word spread quickly through the Allied forces in North Africa. Soon, Charlie's team was transferred to the newly formed 10th Air Recovery and Repair Unit, tasked with a seemingly impossible mission: create a functional squadron of captured enemy aircraft to supplement Allied air power during the critical North African campaign. January 15, 1943. Allied Air Support Headquarters, Cairo, Egypt. Charlie stared at the collection of technical diagrams spread across the table as senior officers from 3 nations looked on skeptically. The room was cool compared to the desert heat outside, but sweat still beaded on his forehead under the intense scrutiny. "Gentlemen, the fundamental problem isn't mechanical, it's philosophical," Charlie explained, pointing to the detailed cross-section of a Messerschmitt engine. "We've been treating these captured planes as if they're broken Allied aircraft. They're not. They're perfectly engineered machines designed for a different supply chain." Group Captain Harrison of the RAF frowned. "That's precisely the issue, Hammond. Different fuel specifications, different hydraulic pressures, different tooling. The incompatibilities make them unusable." Charlie nodded. "But what if we stopped trying to make them compatible with our systems and instead created a translation layer?" The gathered officers exchanged doubtful glances as Charlie pulled out his key diagram, a device he called an interface adapter. It wasn't elegant. The rough sketch showed a complex arrangement of valves, pressure regulators, and filters that would sit between the aircraft's original systems and the Allied supply chain. The Messerschmitt Bf 109F needs 87-octane fuel with specific additives. We have 100 octane. Instead of rebuilding the entire fuel system, this adapter will effectively lie to the German engine, making our fuel appear to be what it expects. Colonel Davis leaned forward. And you believe this can work across different aircraft types? With modifications, yes. The principle is the same. We're building translators, not replacements. The biggest challenge wasn't the fuel systems, though. As Charlie explained, each captured aircraft presented unique problems. The Messerschmitt's hydraulic system operated at 1,520 psi, while American systems typically ran at 1,200 psi. The electrical systems in German aircraft used 24 volts direct current, while many American planes used 12 volts. And then there's the ammunition problem, Charlie continued. German 20mm cannons use ammunition that doesn't match our stocks. Major Gillespie from Ordnance interrupted. That's an insurmountable issue, Hammond. We can't manufacture German ammunition specifications in the field. Charlie smiled for the first time in the meeting. Actually, sir, we don't need to. He pulled out another diagram. The German MG 150-120 cannon can be modified to accept our 20mm rounds with a simple feed ramp adjustment and head spacing modification. It's not ideal for long-term use, but it will work. As the meeting continued, Charlie laid out his complete vision. Each problem had a solution, none of them elegant, all of them effective. The gathered officers gradually shifted from skepticism to cautious interest as the comprehensive approach became clear. Hammond, this is highly unorthodox, General Stevens said finally. The conventional wisdom is that captured aircraft are intelligence assets, not combat resources. With respect, sir, we can't afford conventional wisdom. We're losing the air war in North Africa. Every flyable aircraft matters. After 3 hours of technical discussion, Charlie received conditional approval to proceed with a single test conversion. A relatively intact Messerschmitt Bf 109F captured near Tobruk. 2 days later, Charlie and his team were elbow deep in the Messerschmitt systems. The plane sat in a makeshift hangar, its distinctive cross insignia already painted over with Allied roundels. The Germans really built this thing differently, commented Sergeant Wilson as he struggled with the metric fittings on a hydraulic line. Everything's backwards from what we're used to. Charlie nodded as he carefully measured the bore of the MG 151 cannon. That's the point. Different design philosophy, not better or worse. They built for precision at the factory level. We build for field maintenance and adaptability. The first major breakthrough came on day 4, when Charlie successfully tested his fuel system adapter. The Daimler-Benz DB601E engine roared to life on Allied aviation fuel, running smoothly despite the different fuel composition. "It's working!" shouted Private Jenkins over the engine noise. Charlie grinned but shook his head. "It's running, not working. Big difference." Each system presented new challenges. The oxygen system used fittings that couldn't connect to Allied masks. The radio operated on frequencies outside standard Allied bands. The instrumentation used metric measurements and different color coding for warnings. For each problem, Charlie's team developed a field-expedient solution. They created adapter plates for the oxygen systems, installed secondary radio units, and placed small conversion cards on the instrument panel to help Allied pilots interpret the readings. By the end of the second week, they had a Messerschmitt that could theoretically be operated by an Allied pilot using Allied supplies. The aircraft looked like a mechanical Frankenstein, its clean German engineering now cluttered with adapter boxes, secondary systems, and handwritten instruction labels in English. "It's ugly as sin," admitted Charlie, as they prepared for the crucial engine test. "But beauty isn't the point." The test day arrived with a crowd of skeptical officers and pilots gathering to witness what most expected to be a failure. A brave test pilot named Lieutenant Palmer approached the modified Messerschmitt with visible apprehension. "You sure this thing won't blow up on me, Hammond?" Palmer asked, only half joking. Charlie handed him a simplified checklist he had created. "Follow this exactly. Treat the throttle gently until you're above 2,000 feet. The response will feel different from our P-40s. As Palmer climbed into the cockpit, Charlie felt the weight of every doubtful stare. If this failed, the entire program would be shut down. If it worked, they might change the course of the air war. The Daimler-Benz engine coughed, sputtered, then roared to life. The Messerschmitt, now bearing British roundels over its original German paint, began to taxi. Charlie held his breath as the aircraft accelerated down the runway, lifted off, and climbed into the Egyptian sky. For the next 15 minutes, everyone watched as Palmer put the converted fighter through basic maneuvers. When he finally landed and taxied back, his face told the story before he could open the canopy. "It flies," Palmer announced with a stunned expression. "It actually flies like it's supposed to." General Stevens stepped forward. "Impressions, Lieutenant?" "It's different, sir. The controls are more sensitive than our fighters. The sight picture is off. But," he looked at Charlie with newfound respect, "it's a perfectly good fighter aircraft." Charlie knew this was just the beginning. Making one plane fly was a proof of concept. Creating a sustainable program to convert enemy aircraft into Allied assets would require standardization, training, and overcoming the deep institutional resistance to such an unorthodox approach. But as he watched the general studying the flying Messerschmitt with new interest, he knew he had won the critical first battle. Proving the impossible was merely difficult. February 8, 1943. Desert Airstrip 27, 40 miles west of Tobruk, Libya. Dawn painted the sky in bands of orange and purple as 5 aircraft sat on the improvised runway, their silhouettes unmistakably German despite the hastily painted Allied markings. Charlie Hammonds walked the line, checking each conversion one final time. In just 3 weeks, his team had transformed captured enemy planes into something unprecedented, a functional Chimera squadron of hybrid aircraft. "Final checks complete on all 5, sir," reported Sergeant Wilson, clipboard in hand. 3 Bf-109Fs, 1 FW-190A, and the Machi C-202. Charlie nodded, his expression tight with concentration. "Fuel adapters secure. Double-check the pressure gauges on the 190. That Focke-Wulf's BMW engine runs hotter than the others." The expansion from 1 test aircraft to 5 operational planes had pushed Charlie's team to their limits. Each conversion required approximately 340 man-hours of specialized labor, with the FW-190 proving particularly challenging due to its BMW 801 radial engine, fundamentally different from the liquid-cooled inline engines of the other fighters. "Hammond!" Major Ellsworth's voice cut through the pre-dawn quiet. "The pilots are ready for briefing!" 5 pilots had volunteered to fly the converted aircraft on their first operational mission, a fighter sweep ahead of a bombing raid on German supply depots near El Agheila. All 5 were experienced combat pilots, with at least 10 confirmed kills each. They needed to be. Flying these hybrid creations would require exceptional skill. In the briefing tent, Charlie faced the skeptical expressions of the pilots. Captain James Reynolds, the squadron leader, voiced what everyone was thinking. "Let me get this straight. You want us to fly into combat in enemy aircraft that have been jury-rigged to accept our fuel and ammunition?" Charlie didn't flinch. "These aren't jury-rigged, Captain. They've been systematically converted with engineered adapter systems. Every critical component has redundancies." He unfolded a large diagram showing the cockpit layout of the Messerschmitt. "The original German controls remain unchanged. What we've added are these supplementary gauges and indicators." He pointed to small additional instruments clustered on the right side of the panel. "The conversion status indicators tell you if the interface systems are functioning properly." Lieutenant Parker, assigned to the Focke-Wulf, raised his hand. "What happens if the adapter fails mid-flight?" "The bypass valve here." Charlie pointed to a red handle added to the left of the seat. "We'll switch you to the emergency fuel system. Good for about 20 minutes of flight at cruise power, enough to get home." For 45 minutes, Charlie walked the pilots through every modification, every emergency procedure, every quirk of their hybrid mounts. Despite his confidence, he knew the risks were substantial. These were experimental aircraft being thrown directly into combat. At 0630 hours, the 5 pilots climbed into their cockpits. Charlie helped Captain Reynolds strap into the lead Messerschmitt, performing a final check of the adapter system. "Remember, gentler throttle movements than you're used to," Charlie advised. "The German fuel injection responds differently from our carburetors." Reynolds nodded, his expression now focused rather than skeptical. "If this works, Hammond, you're either getting a medal or a court-martial for unauthorized innovation." Charlie stepped back as the first Daimler-Benz engine coughed to life. One by one, the 5 fighters, machines designed and built to kill Allied airmen, roared into operation under Allied control. The sound was distinctive, especially the Focke-Wulf's BMW radial, with its deeper, throatier growl compared to the higher-pitched scream of the Allison engines in American P-40s. As the aircraft taxied toward the runway, Charlie felt a knot in his stomach. All the testing, all the calculations, all the improvisations were about to face the ultimate test. Actual combat conditions. The first Messerschmitt accelerated down the dirt strip, lifting gracefully into the dawn sky. 4 more takeoffs followed in quick succession, and Charlie watched until the 5 fighters were mere dots heading toward enemy territory. 4 hours later, the radio crackled with the first report. "Chimera leader to base. Mission successful. Engaged 12 Ju-87 Stukas and 6 Bf-109 escorts. We shot down 3 Stukas and 2 109s. No losses. Enemy completely confused by our aircraft." A cheer went up from the ground crew, but Charlie remained silent, waiting for the second part of the report. The technical performance. "Aircraft performance exceptional," Reynolds continued. "The 190 experienced minor fuel pressure fluctuations above 20,000 feet. The Machi's radio adapter failed. Otherwise, all systems functioned as designed." When the 5 aircraft returned, they taxied to a stop amid a crowd of previously skeptical officers now buzzing with excitement. General Stevens himself had arrived to witness the results. The pilots climbed down, their faces showing a mixture of exhilaration and disbelief. "It's the damnedest thing," Captain Reynolds reported, still breathless from the mission. "The Germans couldn't figure out what was happening. Their recognition signals showed friendly aircraft, but we were firing on them. Complete chaos in their formation." General Stevens turned to Charlie. "Hammond, I owe you an apology for my skepticism. This changes everything." He gestured toward the aircraft. "How quickly can you scale this operation?" Charlie did some quick calculations. "With proper resources, we could convert 2 aircraft per week per team. Give me 5 teams, and we could deliver 10 operational captured fighters weekly." Within days, the Chimera program received official sanction. Resources poured in: tools, personnel, captured aircraft from across the North African front. Charlie's team expanded from 12 specialists to over 60, organized into 5 conversion units. A standardized procedure manual was developed, formally documenting the adaptation processes. By early March, 23 converted enemy aircraft were operational with Allied squadrons. The psychological impact proved as valuable as the material gain. German pilots reported confusion and hesitation when encountering what appeared to be their own aircraft. Several Luftwaffe pilots had been shot down while momentarily hesitating to fire on what they thought were friendly planes. Charlie stood on the edge of the airfield one evening, watching as a mixed formation of P-40 Warhawks and converted Bf-109s practiced formation flying. The incongruous sight, American and German designs flying side by side in cooperative harmony, represented something profound. "You've created quite a monster, Hammond," Major Ellsworth said, joining him at the perimeter. "Not a monster, sir," Charlie replied, watching the aircraft bank in perfect unison against the setting sun. "A chimera, different parts forming something entirely new." As night fell over the desert, the implications of Charlie's innovation were still unfolding. What had begun as a desperate improvisation was evolving into a systematic program that would challenge fundamental assumptions about air warfare. April 2nd, 1943. Operational Headquarters, Allied Air Forces, North Africa. Maps covered the walls of the underground command center, illuminated by harsh electric lights that cast sharp shadows across the faces of the officers gathered for the morning briefing. Charlie Hammonds stood before the assembled group, his hands steady despite having worked through the night. On the large situation table, small wooden aircraft models, some painted in Allied colors, others in the distinctive camouflage patterns of the Luftwaffe, represented the current air assets across the theater. Gentlemen, as of 0600 hours this morning, Chimera Squadron has accumulated 178 confirmed combat sorties with a remarkable 31.4 kill-to-loss ratio, Charlie reported, moving several markers across the map. That's a success rate nearly double that of conventional squadrons operating in the same combat zones. Colonel Peterson from Intelligence stepped forward. The psychological impact has been even more significant than the raw numbers suggest. Luftwaffe communications we've intercepted show confusion and hesitation among their pilots. They've implemented new recognition protocols 3 times in the past month, and still can't effectively counter our converted aircraft. The Chimera program had expanded far beyond Charlie's initial expectations. 7 dedicated conversion facilities now operated across North Africa, from Egypt to Algeria. Standardized procedures had reduced conversion time from 340 man-hours per aircraft to just 185, allowing for faster deployment of captured planes. General Stevens pointed to the map sector covering the central Mediterranean. Hammond, we're planning Operation Husky, the invasion of Sicily. Air superiority will be critical. Can your conversions operate effectively in that theater? Charlie nodded confidently. Yes, sir. We've already begun modifying our conversion packages for maritime operations. The Bf-109G models we've captured have excellent range with our supplemental fuel system modifications. The meeting continued with operational details, but everyone knew the true test of Charlie's innovation would come in the next 48 hours. Operation Sandstorm, a massive air offensive against Luftwaffe bases in Tunisia, would deploy the largest concentration of converted enemy aircraft yet assembled. 32 former German and Italian fighters flying alongside conventional Allied squadrons. As the briefing concluded, Charlie returned to the main hangar where his original team was performing final checks on a newly captured FW-190A4, the most advanced version of the formidable fighter yet to fall into Allied hands. Its BMW 801D2 engine represented a significant improvement over earlier models, but also presented new conversion challenges. The supercharger pressure regulation is completely different on this variant, Sergeant Wilson explained, pointing to a complex arrangement of tubes and valves in the engine compartment. Our standard adapter won't work. Charlie studied the system, his mind working through the problem methodically. The principle is the same, but we need to recalibrate the pressure differential. Hand me that pressure gauge. For 2 hours, they worked to develop a new adapter variant that could handle the improved supercharger system. This was the pattern that had defined the program's success: continuous adaptation, refusing to accept impossible as an answer to technical challenges. As dusk approached, the distinctive sound of aircraft engines announced the return of the day's Chimera patrol. 3 converted Bf-109Fs and 2 Machi C-202s escorting a damaged B-17 bomber. The B-17's outboard engine was smoking badly as it limped toward the runway. That's Reynolds' squadron, Charlie said, recognizing the aircraft markings. They hurried outside to meet the returning pilots. Captain Reynolds climbed down from his Messerschmitt, his flight suit soaked with sweat despite the cooling evening air. His expression told the story before he spoke. We found that bomber being pursued by 8 FW-190s about 80 miles northeast of here, Reynolds reported. The bomber had lost its escort and was taking heavy damage. We intervened and drove off the attack. Any losses? Charlie asked. Lieutenant Parker took cannon fire through his wing, but managed to land at the forward strip. The rest of us are intact." Reynolds pulled off his flight helmet, revealing a face etched with fatigue and exhilaration. The bomber crew couldn't believe their eyes when they saw Messerschmitts coming to their rescue. The radio man actually started firing at us until they realized we were friendly. Charlie smiled, but his attention was already shifting to the aircraft. "Any technical issues?" The Mackeys both experienced the overheating problem we've been tracking. Had to keep power below 85% above 15,000 feet. The 109s performed flawlessly. 3 days later, Operation Sandstorm commenced at dawn. Waves of Allied bombers, B-17s, B-24s and RAF Wellingtons, struck Luftwaffe airfields across Tunisia. The converted fighters of Chimera Squadron flew escort, deliberately positioned at the vanguard where German defenders would encounter them first. The strategy worked brilliantly. German fighters, spotting what appeared to be friendly aircraft escorting enemy bombers, hesitated critically in their initial response. By the time Luftwaffe pilots realized the deception, conventional Allied fighters had arrived in force, catching many German aircraft during takeoff or low on fuel. Charlie monitored the operation from the command center, tracking the reports as they came in. By midday, it was clear that Sandstorm was achieving unprecedented success. Luftwaffe losses were estimated at 64 aircraft destroyed on the ground and 29 in air combat. Allied losses totaled 17 aircraft, including just 2 from Chimera Squadron. As the exhausted pilots returned, Charlie moved from plane to plane, checking conversion equipment performance and collecting technical data that would inform future modifications. Despite the operation's success, he remained focused on the engineering challenges: the Machi overheating issue, fuel consumption variances in the Messerschmitts, ammunition feed problems in the FW-190s. "Hammond," General Stevens called, approaching with a group of senior officers, including several wearing British uniforms. "These gentlemen from RAF Middle East Command would like a word." Air Commodore Whitworth of the RAF stepped forward. "Mr. Hammond, your Chimera program has proven remarkably effective. We're interested in implementing similar conversions in the India-Burma theatre, where we've captured numerous Japanese aircraft." Charlie's mind immediately raced through the technical implications. Japanese designs used entirely different philosophies, different materials, different fuel systems. A whole new set of challenges. "It's possible, sir, but would require developing new conversion packages specific to Japanese engineering approaches." "Precisely why we need you in Burma, Hammond," Whitworth replied. "A transport leaves for Cairo tomorrow, connecting to India. You and a core team will establish a conversion facility near Imphal." That evening, as Charlie packed his essential tools and notes, he paused to watch a mixed formation of P-40s and converted Bf-109s landing after the day's final mission. What had begun as a desperate improvisation on a single captured fighter had evolved into something that was changing the fundamental dynamics of air warfare. Beyond the technical achievement, Charlie recognized something deeper in the Chimera program's success, a testament to human adaptability, to the power of understanding your enemy's thinking so thoroughly that you could turn their own creations against them. There was a certain poetry in that, a symmetry that transcended the mechanical details. Tomorrow would bring new challenges in a new theatre against a new enemy. But the principle remained the same. Nothing was truly incompatible if you understood it deeply enough. May 8, 1945. National Air Museum, Washington, D.C. A modified Messerschmitt Bf 109G6 hung suspended from the ceiling of the exhibition hall, its once lethal lines now frozen in peaceful display. Below it stood Charlie Hammonds, older and thinner than he had been in the North African desert, watching as museum workers carefully positioned a placard describing the aircraft's unique history. The distinctive Allied roundels, painted over the faint outlines of Luftwaffe crosses, told the story of adaptation that had changed the course of aerial warfare. "Is it positioned correctly, Mr. Hammonds?" asked the museum director, clipboard in hand. Charlie nodded, his eyes fixed on the aircraft. "Yes, that's right. You can still see the adapter manifold through the engine access panel. That's important. It shows the heart of the conversion." The Messerschmitt was one of only 3 surviving Chimera aircraft brought back to the United States after the war. This particular plane had flown 27 combat missions under Allied control, scoring 7 confirmed kills against Luftwaffe aircraft, a mechanical turncoat that had fought with distinction against its own kind. By the final tally, Charlie's innovation had resulted in the successful conversion of 367 enemy aircraft for Allied use, 248 German, 87 Italian, and 32 Japanese. These converted fighters had flown 2,641 combat sorties, destroyed 197 enemy aircraft in aerial combat, and conducted countless ground attack missions. The program had expanded from North Africa to the Mediterranean, Burma, and finally the Pacific, where converted Japanese Ki-43 Oscar fighters had flown reconnaissance missions ahead of the American island hopping campaign. More significant than the raw numbers was the psychological impact. Enemy pilots never developed an effective countermeasure against the confusion created by seeing their own aircraft in combat against them. Intelligence reports estimated that the program had reduced enemy fighter effectiveness by 14% in tactical engagements where converted aircraft were present. The President will be arriving in approximately 20 minutes for the dedication ceremony, the director reminded Charlie. Is there anything else you'd like to verify before then? Charlie shook his head. The technical details of the display were accurate, though they couldn't capture the desperate improvisation, the sleepless nights, or the acrid smell of engine exhaust mixed with desert sand that had defined the program's birth. As the museum staff made final preparations, Charlie wandered through the exhibit. Display cases held the tools his teams had developed, specialized wrenches for German metric fittings, adapter gauges for Italian hydraulic systems, the pressure regulators that had allowed Allied fuel to power enemy engines. Each artifact represented a problem solved, an impossible barrier overcome. A wall of photographs showed Chimera aircraft in action, a Bf-109 with RAF roundels flying alongside a Spitfire, American pilots standing proudly beside their converted Focke-Wulfs, the first Japanese Nakajima Ki-43 to fly under American control, taking off from a jungle airstrip in Burma. Charlie paused longest at the memorial section. 27 pilots and 14 ground crew members had lost their lives in the Chimera program. Flying converted enemy aircraft had always carried additional risks beyond the normal dangers of combat. Systems failed, adaptations proved inadequate under extreme conditions, and sometimes Allied anti-aircraft gunners or friendly fighters mistook the converted planes for enemy aircraft despite their markings. "Mr. Hammonds," called a voice from behind him. Charlie turned to find a young man in an Air Force uniform, perhaps 20 years old, with lieutenant's bars on his shoulders. "Lieutenant Roberts," the young officer introduced himself. "My father flew with Chimera Squadron in Tunisia. He always said your conversions saved more Allied lives than anyone would ever know." Charlie shook the offered hand. "Your father was one of the brave ones. It took real courage to climb into those planes knowing they weren't designed for our side." The dedication ceremony began promptly at 1400 hours, with dignitaries from every Allied nation present. The Secretary of War spoke about innovation and American ingenuity. The Air Force Chief of Staff emphasized the program's strategic impact. But it was the final speaker who caught Charlie by surprise, Captain James Reynolds, now wearing the eagles of a full colonel, who had flown more Chimera missions than any other pilot. "The official reports and statistics don't tell the real story," Reynolds said, his voice carrying through the hall. "They don't capture what it meant to sit in a cockpit designed by your enemy, surrounded by gauges labeled in German, with the knowledge that one adapter failure could leave you stranded over hostile territory in an aircraft that your own side might shoot down by mistake." Reynolds gestured toward Charlie in the front row. "This man didn't just solve engineering problems, he changed how we think about adaptation in warfare. The Chimera program taught us that understanding your enemy's technology thoroughly enough to use it against them represents the highest form of technical intelligence." After the ceremony, as the crowd dispersed toward the reception, Charlie remained alone with the suspended Messerschmitt. His work had largely gone unrecognized during the war itself. Classified as top secret and overshadowed by larger technological developments like radar and proximity fuses. The Chimera program had received just 3 paragraphs in the official Air Force history of the war. But Charlie had never sought recognition. The satisfaction had always been in the solving of problems, in making the impossible work. His innovations had since found peacetime applications. The principles of adaptation and interface design he pioneered had influenced post-war aviation development, particularly in standardizing aircraft systems across international boundaries. After the war, Charlie had declined offers from aircraft manufacturers, choosing instead to return to Detroit and the automotive industry. There, he applied the same principles of cross-platform adaptation to civilian vehicles, developing universal component interfaces that revolutionize parts interchangeability between different manufacturers. As museum visitors began to filter past the Messerschmitt display, Charlie overheard their conversations, expressions of disbelief that enemy aircraft had been successfully converted for Allied use, questions about how such adaptations were possible. A young boy, perhaps 10 years old, peered at the aircraft with wide eyes. "Mister," he asked, noticing Charlie's special access badge, "did that plane really start as a German fighter?" Charlie nodded. "It did. This very plane was built in a factory near Munich to fight against America." "But how did we make it work for us?" the boy asked, his face scrunched in confusion. Charlie considered the complex technical explanation, then smiled. "We learned to speak its language. When you understand how something thinks, even a machine, you can find common ground." As Charlie finally turned to leave, he glanced back once more at the Messerschmitt. The aircraft represented more than a technical achievement or a historical curiosity. It embodied a philosophy that had guided his entire career. Boundaries between incompatible systems existed primarily in the minds of those who hadn't looked deeply enough for connections. In the decades that followed, as the Cold War pushed aviation technology to new heights, elements of Charlie's adaptive design philosophy quietly influenced aircraft systems on both sides of the Iron Curtain. The principle of designing interfaces between incompatible systems became fundamental to the computer revolution, though few remembered its origins in the desperate improvisations of a mechanic in the North African desert who refused to accept that enemy planes couldn't be made to serve Allied pilots. Charlie Hammonds died in 1978, aged 68, having registered 37 patents based on his adaptive interface designs. His obituary in the Detroit Free Press made no mention of the Chimera program. But in classified Air Force technical schools, in engineering programs studying adaptive systems, and whenever pilots or mechanics faced seemingly incompatible technologies, the spirit of his innovation lived on, a testament to the human capacity to turn adversity into advantage through understanding, adaptation, and the stubborn refusal to accept that something cannot be done.